Okay, so if these are our two lines and we have two more lines, x equals 2 and x equals 5, we want to find the area the parallelogram forms. So let's see, x equals 2 is going to appear about here. And x equals 5 is going to be way out here, so I got to extend my lines, maybe make that one a little straighter. So let this represent the parallelogram.
So x
Okay?
equals 2 and x equals 5, so.
Yeah. So here's x equals 2.
That's x equals 5.
And here's x equals 5. So here's our parallelogram. Now let's just verify that my graph is reasonable. Of course, I drew my line right through my 3. But this line is going to have a y-intercept of 4 and a slope of 3, right?
X equals 2.
So it's pretty clear that I take 0, 4, move with a slope of 3. This line has intercepts. Well, if x is 0, y is negative 2. So there's my y-intercept, right? And if y is 0, x equals negative 4 over negative 6, which is 3/2. So my x-intercept is 3/2, 0, and there are the equations, or there are my lines, and here's my x equals 2 and my x equals 5 line. Okay? They're not drawn to particularly good scale, but one thing that I can say then is that if my, where's all my good chalk? Okay, my base,
Elena.
okay, this is going to be my base. And this is exactly what we did in class last time. Okay?
Base.
Base of my parallelogram. We'll talk a little bit more about parallelograms, but what do you know then about the altitude of a parallelogram? Never talked about it last time, but make sure, especially in this MCR class, that we understand this, okay? Well, okay, let's just talk in general about parallelograms before we try to apply the properties of parallelogram to this picture, okay? So if I have a parallelogram, and often the parallelogram will be drawn like this, okay? And we'll use this side for the base. Now we could use either side for the base. It wouldn't matter. Okay? Now, if I had this cut out of a piece of paper, gave you a pair of scissors, could you make one cut in this thing and reassemble it to make a rectangle? Where would you cut it?
All
Here,
right.
come on up, cut it.
Okay.
Mind being on camera?
I'll do the cutting.
You can keep your back to the camera, you know. Okay? Okay, you cut it there, and then you're going to take this thing and glue it over here, right?
Yeah.
Okay? Yeah, stay anonymous if you possibly can. Okay, so this gets cut and moved over to here. So it's not here anymore, and now we have the perfectly good rectangle. Right? So this is my base, and this is going to be my altitude. Okay? And we see then that the area of this rectangle has to be the same as the area of the original parallelogram. But now the area is just the length of the rectangle times the width. I don't know which one you want to call the length and which one you want to call the width. That depends on how you want to think about it. Doesn't matter. One of these is the length, the other is the width. And usually the length, you might think of the length as the one that's greater, but that's not absolutely even necessary, okay? Makes no difference which one you call the length, which one you call the width. You multiply them to get the area of the rectangle. And we hopefully are familiar with that and why that works. Okay, we could talk more about why that works, but let's just accept for now that it works. Well, that's equal to the area of the parallelogram, right?
So then basically the altitude is the length. Or it could be either length, you said the length could be either altitude or base. It doesn't
I'm sorry.
matter.
Once more.
You said the length could be altitude or base, it doesn't really matter.
Yeah, when you got a rectangle, it doesn't matter which one you call the length and which one you call the width, right?
Okay.
Okay? And so it wouldn't matter. Well, in this case, it does matter. The base is the one, well, the altitude is what you get when you cut the thing, okay?
Okay.
Now, there's another way it could have been cut, but we're not going to worry about that right now, okay? Now, the whole point you want to see is, again, the area of the parallelogram is the same as the area of this rectangle because you just reassembled the same stuff to make the rectangle. So the area of the rectangle is the base times what you call the altitude, right?
Yeah.
Okay? Now, the altitude is the same as this, okay? So this is also an altitude, and so is this. I mean, the base, well, this base and this, these are parallel. This side of the original parallelogram and this are parallel because that's what a parallelogram means. Okay? And that's why this fits here. This is parallel to this, right?
Yeah.
So they fit together. Okay? So this is what we'll use for base and altitude, but the altitude is equal to this and also to this. Okay? So when we look at a parallelogram, we can say we don't have to necessarily reconstruct it, although it's fine to do that. You can just say, okay, if I reconstruct this, I know the altitude is going to be this. And also, I mean, this does form a rectangle because these angles are all equal and so forth. So we know it's a rectangle because this is going to be a right angle. We cut this at a right angle, right? So we make sure we cut at a right angle here. So every one of these altitudes is parallel to the others, has to be at a right angle to the base, right? So if this is going to be an altitude, this has to be a right angle. Okay? So now we use this altitude and we'll say the altitude's at a right angle to the base, and it runs from the base to a vertex. Vertex, well, there's a vertex here, 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 and here, right? Now, if we're going to call this the base, then we could run from here to here, and that would be an altitude, right? Because this is a vertex, base to vertex, right?
So the vertex is the point in the corner.
Yeah, it's a point where two sides meet,
Okay.
okay? Then another thing we could do, though, there is another altitude that goes to vertex, but you have to extend the base.
So,
But okay? Because sometimes you don't even have a vertex directly above the base. But if you think about how you would deconstruct this thing, it's clear that that's what you need to use when you reconstruct the rectangle. Okay, it's clear that's going to be the length or width perpendicular to this base, right? Okay, so you can extend base. You can extend the base.
So extending the base is it just like reconstructing it? How you slice it and add it on the other side?
Yeah.
Okay.
Yeah. And of course, we could consider this to be the base and then an altitude to the opposite vertex would be here. But it's the same. We could use this, we could use this, we could use this, right?
Yeah.
Because any one of them is going to give us this dimension of this rectangle. Okay? So there's our rule. If our altitude is constructed from what we choose to be the base to a vertex, okay, then it works. We could also say, well, an altitude could be any line segment from the base to the side parallel, right? So an altitude could also go from here to here. Now that's not the way I wrote it, but this distance is going to be the same as this one, because right angles and so forth, okay? I want to get into the details of the geometry. So you could also think of an altitude as running from the base to the parallel side, at a right angle to the base in every case.